All right, IB Physics. This is a little quick walkthrough of problem number 1 on our proportional reasoning assignment to help you think through how to do this proportional reasoning thing. So there's actually a lot of different ways you can approach proportional reasoning. So I'm going to go over a couple of ways that I like to think about it, and you can kind of think about what makes the most sense to you. So first off, one way that you can think about proportional reasoning is go ahead and consider what we know. So here we have grocery cart A and grocery cart B. And grocery cart A is pushed from rest with an acceleration A. So A is its acceleration. Grocery cart B has twice the mass of cart A. So I can say that it has twice the mass, and that means cart A has mass M. Cart B would have 2m. And we don't know the acceleration of B, so that's like a question mark. And then they're pushed with the same force. So they're both pushed with the exact same force. So how does the acceleration of B compare to the acceleration of A? So the way that I, like my personal preference for approaching these problems is that I like to consider it by writing it down like this. So I've written down the stuff I know and what I want to know, which is what is this acceleration? Notice that I kind of like lined them up. If I were doing this on a lined paper, it'd be nicer. And then I think about, oh, I know that there's this relationship, Newton's second law, F equals ma. And for grocery cart A, just follows this equation. For grocery cart B, it's still going to follow that same equation. F equals ma has to be true, but we have a different mass. So now the force is going to equal 2 times the mass and something times the original acceleration. And so I know that this equation, F equals 2m question mark A, has to like cancel out, has to be the same as F equals ma. The same relationship has to hold true. Notice that the force is the same in both of them, so I've left that same. And so essentially what I've done is I've written down this is the mass for B, and this is going to be the acceleration for B. So then I just have to think mathematically, well, what would be the acceleration right there? Well, I would go ahead and say, I know that the 2 has to go away. So to have that happen, I have to have a 1/2, because 1/2 times 2 will cancel out, and then I'll just be left with the m and the a. So that means that right here is 1/2 the acceleration of A. So I can say that B's acceleration is 1/2 A's acceleration, or 1/2 A, the acceleration of A. It's confusing that it's cart A and cart B, I know. So that's the way that I typically think about this problem. It's my sort of favorite way of thinking about proportional reasoning. But there's other ways that you can think about proportional reasoning. So another way that we could think about it is by considering the relationship between the two things. So I still have these same knowns that I know that I'm trying to see what is the acceleration of B, what is B's acceleration. And we know that the thing that changed is the mass. I'll just write out the whole word. The change is the mass. So another way that I could do this is I could say, well, what is the relationship between mass and acceleration? So I have this equation, Newton's second law of motion, F equals ma. The net force is equal to the mass times the acceleration. But that doesn't make it super clear what the relationship is between acceleration and mass. So what I'm going to go ahead and do is solve for acceleration. So that means that I would divide both sides by m. So now I have an equation that says the acceleration is equal to F over m. And this, F over m, is in fact an inverse relationship. So this is like saying y is equal to some constant, that's the force, over x, which is the mass. So this is an inverse relationship. And so because it's an inverse relationship, I know that if the mass doubles, so if m doubles, then the acceleration is going to do the inverse of that. Acceleration will do the inverse of double, which is half, multiplied by 1/2, or you could think about that as in terms of the acceleration will be divided by 2. So that's another way that you can think about the proportional reasoning. So there's actually lots of ways you can do this. There's even more that I could go into on like ways you can approach this. Some students, when they come up to a proportional reasoning problem, don't love doing this sort of mathematical modeling. And I hear you. It's really useful to be able to do, but I understand that it's not the easiest thing ever. And so some students actually take the approach of assigning numbers. So you could do that by let's actually grab all of this and move it over. Sorry. I can do it, maybe. So some students would actually go ahead and assign numbers. And you could say, well, I've got cart A and cart B. And this does work. I will tell you that it's more work over like time, you know? So I could say that we know F, M, and A are all part of the things that we might know. I could set up a little table and then I could make up fake numbers. It's totally fine. It'll still work out because physics holds true, math holds true, even if we're making stuff up. So cart A pushed from S has an acceleration. So then I would say, well, what's an easy number for an acceleration? Well, 1 meter per second squared is an easy number. There we go. Then I would say, okay, cart B has twice the mass of cart A. So again, what's an easy number for our mass? Well, I could have cart B have a mass of 2 kilograms, and then cart A have a mass of 1 kilogram. Pretty great. So cart B has twice the mass of cart A. Done. Then they're pushed with the same force. Okay, we can do that. So they're pushed with the same force. So what's an easy number for force? Well, an easy number might be 1 Newton. Do these have to all be 1? No. What's another easy number? Oh, Ms. Getz, you're doing this kind of wrong. What's another easy number? Well, you might point out, hey, Ms. Getz, you've been missing a key aspect here, and I have. It's because I don't usually do it this way, because assigning numbers is more work. Now that I've assigned numbers for 2 of these quantities, I have to actually combine them together to say, oh, the force equals the mass times the acceleration. So 1 times 1 equals 1 kilogram times 1 meter per second squared equals 1 Newton. Again, this is not how I usually approach this problem. So sorry, I'm doing it not exactly the clearest possible. So then what I would go ahead and do is say, well, I know that they have to have the same force, 1 Newton, and then I'm looking for this acceleration. That's the variable I'm trying to find. So I would go ahead and, again, write down my F equals ma over here for card B. Now I want to find the acceleration, so I'll solve for acceleration. Acceleration equals force over mass. I'm doing that with letters algebraically so that I know what I'm doing and so that someone who's looking at my work knows what I'm doing. And then I'm going to take the force, which is 1 Newton, and divide it by the mass, which is 2 kilograms. And so 1 divided by 2 is equal to an acceleration of 1/2, 0.5 meters per second squared. And so we get the answer that it is 0.5 meters per second squared. And so that would say, aha, the acceleration is half of what it was originally. I think doing numbers takes longer, and if you can build this algebraic understanding, either in terms of the relationship or in terms of the algebra that you write down, and consider how to make the equation cancel out to still be the same equation, I think it's a little bit easier. So those are a couple of approaches for you. Hopefully they were helpful. I think this rest here, where you're actually going to do some calculations, you'll find pretty straightforward. And keep me posted if you have any questions. Our next problems about bikes and dogs are going to be, again, very similar. All of them are focused around Newton's second law of motion here, that the sum of the forces is equal to the mass times the acceleration. Good luck, and you got this.